Hello today guys. So today I'll be showing you guys how to solve the max points on a line problem. So given a array of points on a 2D coordinate plane, we want to find out the maximum number of points that lie on the same straight line. So for example, here you can see that this has 3 points on the same line. And then for this one, for this line, there's 3 points. But then for this line, there's 4 points. So the maximum number of points will be 4. So with the basic mathematical knowledge, you can pretty much see that this problem has to do with some math. And it has to do with figuring out if the points are on a line. And we know very well that from algebra and geometry that we have an equation for that. The basic equation for a line is y equals mx plus b, where y is the y coordinate, x is the x coordinate, m is the slope, and b is just a random constant, the slope, the intercept on the vertical line here. So what we want to do for this problem is that we want to figure out we want to loop through the points, and then we want to see if the points that we're looping through fall on the same line. If they do, then we want to sort of track it, and then so we will increment our count. If not, then we'll skip that and then continue on. So first of all, there's some edge cases we need to handle. So with this problem, it's actually there's some trickiness to it. So for example, if we have given an input such as their duplicates, this will actually give us 2 points, like 2 of the same points on the line, and the result should actually give us 2. So that we need to handle. So we need to handle duplicates. The other one is that if there are only, say, one coordinate given, or there are just no coordinates given, then we want to just return the point, right? Because you can only you can only have 1 point on that line, right? Because itself is going to form a line. So there's none. There's pretend 0. So we can handle this base case for now. What we can do is saying if the length of the point is less than or greater than 2, then we can just return the length of the point, right? And then actually if let's say points does not exist, right? Let's say I guess Python we would do if point equals none, then return 0, right? Because there's no points. So now we're in the case where we can have more than 2 points, and now we can start performing our algorithm. So it's essentially going to be a 2 for loop pass. So a very basic one. Going to iterate through the first point, and then we're going to iterate through the second loop. This time using I as the index, and then we want to increment it so we don't duplicate, and then the rest of the points. And then here we sort of, in the first loop, we want to sort of like, set 1 point, so that it never changes. And then for the other points, that's going to change for other points, right? We want to start iterating because we need 1 point to be sort of stable, constant, so then we can compare with other points to calculate the slope, right? So as we said before, the slope equation is going to be y equals mx plus b, and then so we need to sort of a dictionary to keep track of the slope, right? So we need to keep track of the slope using a dictionary, and like we said in here that we might have duplicates, so we also need to track duplicates, and we can actually just for now just track it using an integer. So let's say 0, right? So there's number of duplicates, and then now we want to start calculating the slope, right? So given like points the first point, the second point, we want to calculate the slope. So let's assume we have a function called calculate slope, and then we can say give me the first point. Let's actually make this kind of, actually no, we should be fine. Just give us the first point. Sorry, it should be points I, and then that's the sort of our what do you call it? The constant point, and then that's our the rest of our points. So if let's see. Okay, so here's another thing we need to do. So going back to this case, right? If there's a duplicate, so for example here, points I and points J would be 1, 1, and 1, 1. Then if they're duplicate, we actually don't want to go through our process, right? We want to track the points inside our duplicate counter instead. So we're going to increment our duplicate here, and then we can continue, but I'm just going to do else statement here. And then what we want to do now is calculate the slope, and if slope is in our slopes dictionary, then slope increment the count. Else we want to register the new entry, right? Okay. So now let's see. Okay, now the fun part. The meat of this problem is in the slope calculation, right? So remember how we said that the slope equation is this? So to actually figure out if a point falls on the same line as another point, we need to basically produce this equation, right? With the slope, the constant, and everything else. And then there's another standardized form for this called ax plus by plus c constant equals 0. That's another form to write this. But we're going to do a little bit trick such that we don't care about this entire equation, but only we care about its m, just the slope. And then we'll show you why we only care about that and why that will work. So let's define a function called calculate slope, which is going to take in first point, let's just say 1 to point 2. Okay, and so we're going to calculate the changing x and changing y. So it's going to be points 1, so first index, minus points 2's first index, and then similarly xy will be points 1's second index minus points 2's second index. And now usually what we should do, we should just return the slope formula, right? So it would be dy over dx. But here's an interesting problem here. So what happens if dx is 0, right? There's going to be a error thrown such as division by 0, and so somehow we need to get past that. And one way we can do is we can return sort of like some infinity value. But there's another way we can actually do this, which doesn't even require us to calculate this fraction right here, but we can sort of, if you remember the division, that we can simplify fractions. And so we need to make sure that somehow we can sort of produce another representation of the simplified fraction, right? Because if we don't simplify it, then you can have two slopes with different values. When simplified, they're the same, but when they're not simplified, they're different, right? For example, if you have 14 over 2 and 7 over 1, if you don't simplify it, they're considered different slopes. But if you do simplify it, then they're the same thing. They're all just going to be registered as 7 over 1. So what we need to do is we need to find the greatest common factor, greatest common divisor, and then that would be, you know, and then we can divide our deltas, the dx and dy, by that normalization to normalize it down to the simplified version, right? So we need to somehow find the normalization divisor, right? Well, I'll just call it divisor. And then, so we need to somehow calculate it, and we can write a function called greatest common divisor, which just taking dx and dy. And then what happens is we can just return dx and dy as a tuple, and tuples can actually, you know, act as a key as well. They're actually, so tuples can act as keys, but list cannot. So that's why we're using a tuple. And then let's write our greatest common divisor function. So let's just say a and b. So this is a very generic function. I'm not going into too much into it, but basically what happens is that you want to recycle those two values. And so you say, and then so basically a and b, either one is going to become the remainder, and then the other one's going to become the greatest common divisor. So while b is not 0, basically, then we want to say, okay, a and b is now going to be b a mod b. So this a mod b becomes the remainder, and b is the greatest common divisor, right? And then what we want to do is just say return a, because b is going to be, we want to use as the sort of the stopping point for when it becomes 0. So when that happens, we return a. So now let's do that. Yeah, we need to put self because it's defined inside this class, and then we can also do self here. Okay, and then so now, after all the iterations done, we can now start calculating the maximum points. So we need to track a max points here. So max points right now will be 0. Oops, 0. And so then we want to, at this point, want to say, okay, max point is going to be the max of the max points and the duplicates, because what can happen is that you can have an array of basically n of the same coordinates, and this will handle that by giving us all the counts of the duplicates. So that handles that, and then now we need to go iterate through our dictionary. So for slope and slopes, right, see if there are any counts here that are greater than the current max points. So we can look at the max of the current max points and the slope, but we also need to account for duplicates here, because when we in this else statement, when we actually increment the slope, we you know, like this duplicates and the slopes are calculated separately, so we need to sort of merge them together at the end here, right? So there we go. And then what we can do, we should just be able to return max points, right? Oh, mess up some here, so we need to actually divide by the divisor, right? And I think I spelled it wrong. Oh, there we go. And here we actually will not run into issues of 0, 0, because so basically dx and dy will never both be 0, 0, because the only point where they can do that is if they're the same points. And when they're the same points, we know that they're not going to go through the calculation. They're going to going inside the duplicates calculation, right? So there's that. Yeah, so we'll never get divisor equals 0. And then Let me just sanity check everything. Okay, so actually there's one more thing. For an example here, let's say for duplicates example, I think we need to do this. So let's say for examples that looks like 0, 0, right? 0, 0, that's one duplicate, and then 1, well, 1, 1, 1, 1, right? So duplicate is 0. Okay, got that. And then so duplicates will be 1 here, and then we go from 0, 0 to 0, 1. What happens is that that's a slope, so slope equals 1, and then we go to 1, 1, then the duplicates becomes 2. Right, well, duplicates become 2 over down here, but and then so at the end when we sum it up, it will actually be 1 plus 2, which is 3, which is wrong because we want 4. And the reason that's wrong is because we need to make this 2 here, because at this point when we have a slope and that's not in the dictionary, there's a 0, 0 and a 1, 1, and so that's actually 2 points in that for that one slope. And then trying to think, so if we do 2 here, would that work? Trying to think about edge cases here. Let's write some more examples. So let's say if there's no duplicates, right? What happens if we do that? Alright, then we just have 1, 1, and then 2, 2. Oh wait, actually we might run into trouble if we have this. Right? Let's say they're all the same. So in our first run, we find duplicates is 1. So we increment it to 1. And then we're done. Right? Because these 2 points are duplicates, but since our for loop initially runs in the first one and then runs on the second one, duplicate only got incremented once, and then the entire operation ended. So what we could actually do is change duplicates into 1 to accommodate for that case, because when we find this other duplicate, we will just plus 1, and then that'll be 2. And then it will also handle this case here, because to make this 2, at the end we add the duplicate here, which is going to be 1. So that shall pass. Let's give this a run. Okay, so that worked. And let's see if our other cases works. Whoops, what happened? Oh, point. Okay, so that worked too. And then let's try our other test case. This should give us, I think, 3. Okay, awesome, that worked too. So let's give it a shot and submit. Oh, okay, so we failed. So what did we do wrong? Okay, that was stupid. After all that time, it was because we returned max points within the for loop instead of outside of the for loop. Okay, now let's try to submit and see if we pass. And we did. Awesome. Okay. So I hope that was helpful for you guys, and leave a comment if you guys have any questions, and maybe I'll make another video to discuss maybe other aspects of this problem, and hopefully those were helpful. Thank you.